plans to mix and match, so you only...
Come on. That is so weird. Okay, good. That's good. That's good. Everything is working. Hello, everyone. Today is the start of the next chapter, chapter 7, where we will talk about how to communicate with databases and specifically how to do so through SQL. Before we begin, let me announce the lesson in the channels because I forgot. Today's lesson is all about data, how we store data, how we access data. And let's start from a problem that is this. If I open this file, you'll notice it's in CSV format, so comma separated values. The first row is a list of fields that every single object has. So we have ID, first name, last name, email, gender, IP address. Simple stuff. And there's 1,000 records in total written in this file. What would we need to do if we wanted to find, say, Shoshana Shea? If we wanted to find this person, what would happen? We would first read the whole file. And we would then perform some kind of a search. What could we do to make it better? We could sort people by their names alphabetically and perform binary search to find the person faster, but it would still be pretty slow. And with an increasing amount of data, the search in this file would become significantly slower. So it's a problem. Inserting data is slow, and looking for data is even slower. So we need to solve this problem somehow. And this problem has been evident and obvious a long time ago. Actually, roughly 50 years ago, people figured out files is not the right way to do it. There has to be a better way to store and get data. And that better way is called a database. Let me draw you a database. I think interactive drawings are the best for learning. I have not practiced in advanced, I must add that. By the way, there is no camera, I just realized for some reason. Why is that? That's unfortunate. Here we go. So, what is a database? Here is a database. And let's mark data with this bubble. And here is data. So data comes into the database. and it comes out of the database. How do we control what data comes in and comes out? We control it through a language called SQL. And how is the data stored? It's stored in tables. And what is a table? It's just a bunch of columns and rows. Should probably do it something like this. So in our case, it would be very similar to CSV. ID, name, last name. 1, 2, 3, John, Cena, because why not? Damien, Ipkinson, Tawny, Stark. So this is data. And actually, if you look at this structure and this structure, you might say, hey, it's still the same thing essentially, right? Well, when we store data in tables, we don't really store them so plain like in a file. We don't really write anything in a sequence. We don't just append a new line and call it a day. We actually do more than that. What do we do? So when data is stored, it's actually stored in an optimized way. For example, if you have to search, I'll create a new one. Let's just open a new paint. This one is useful to keep. So, you know, if you ever worked in a warehouse, there are sections. Section A, section B, section C, for example. And each section has different items. And if I wanted a certain item, if this was a file, I would need to scan every single entry. I would need to check this, is it my file? Is it my entry? 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 And then I find my entry and I say, this is my entry. But in a database, I would do something like this. So if I search for a person by its ID, I would first, so by person by name, more like. So section A has A through F. Section B has G through O. And section C has P through Z, let's say. So if I'm searching for a person named Hijk Kira. If I search for a person named Kira, I really have no reason to scan every record in section A, because I know for a fact that section A has no names that start with letter K. So I'll move on to another section. I know that section B has names that start from G to O, which includes K. So, when I'm trying to get data which is structured like this, I will go right into the section that is relevant instead of scanning everything. And it goes much more complex. Inside this section, I could have more sections, and so on and so on. And this is just overly simplified version of it. What database actually has is a tree-like structure with those sections. So it's just a bunch of trees of data. So it would be like section A, section B, then it would be, I don't know, A, B, and this would be A, this would be B, this would be C, D, for example, and this would be C, this would be D. So instead of doing a linear lookup, I can now do a lookup based on those branches, a binary search or similar. So this is just one way what could happen in a database, but that's what databases do. They optimize the way data is stored. It doesn't just perform a linear lookup. It does a little bit more. How does the database look like in practice? And I would like to show you a real deal database. I mean, how a database is made from scratch and how to connect to it and how to add a few tables to it. So I will demonstrate how to work with databases from Azure, Microsoft Azure, and we will create a Azure SQL database. So I have a free subscription. Everyone can have a free subscription for a year. So I will create a SQL database. It's Azure SQL database in my subscription. I will create a new resource group. I'll call it C# Bootcamp. And I will call the database, let's say we will work with people. Not people, but workplace X. I will not use an existing server because I don't remember the username and password. I'll create a new one. Nice, C# Bootcamp is taken. Oh, only lowercase. No, it's not taken. So it's taken, okay. Wow. So my database name is C# Bootcamp K. The username through which I will log in will be called my name. And I will input a password. And I will let you ruin the database. I don't care. So I will let you know the password. You can try it out yourself. It doesn't matter. Let me think, what password should I write? I'll write ABC123. ABC123, and I'll put 2 exclamation marks. ABC123, 2 exclamation marks. You can ruin it. I don't care. I'll delete it anyways at some point. And let's select region, something in Europe. Europe West makes sense. So this creates a server. Database is something that needs to be on a server, on some physical machine. So I just created one. And I selected C# Bootcamp K. That's the server. I don't care about Elastic Pool. Actually, sure, let's... Actually, no need. Configure database. We'll use the cheapest one. We'll use the cheapest one, so basic. Basic, standard, or premium? Basic. Okay, this is definitely not what I want. So basic one and the smallest one. As you can see, if I increase or reduce the size, it doesn't even matter. So I'll select 2 GB because it's irrelevant. And I click apply. So I have a database for 2 GB in this server where the credentials are written. I won't do any... Actually, the endpoint will be public. Allow Azure services and resource access service. Sure. Public endpoint. I don't care. Use existing data. We will use some sample data. I don't need Azure Defender. I don't need any tags. And that's it. Let's hit create. So this creates a database in Azure, and it takes a little while. So let's wait. So after the database gets deployed, it usually takes a few minutes. We will use SQL Server Management Studio. If you want, you can download it yourself. I highly recommend. It's better than exploring it natively for Visual Studio. The link is here. It gives a little tutorial. So here is the link to it. I'll give both this one and this one. So the first one is more of a general description, and the other one is the actual link for download. Okay, so we have a server deployed, firewall rules created, and the actual database is almost done. Done deploying. So let me open SQL Server Management Studio. It will open in, well, it will pop this window where you need to input the server name. My server name is C# Bootcamp. And I will not use Windows Authentication because it's not on my machine. It's in a different machine. So I'll use SQL Server Authentication, which is basically username and password. So I use my username and I use my password. And I hit connect. And this will connect to the database that I have just deployed. connecting. It should connect, no problem. It actually might fail for security reasons. I am not sure about the security configuration, but I hope that it won't fail. Oh no. Error 53 could not open a connection to SQL Server. Oh, right. It's a different name. Let's use a different one and let's try again. Oh, here we go. So it actually requires my client IP. So it won't allow everyone to access it, probably. Let's continue. Yeah, sure. I really hate this approach. So many windows asking me to do the same. Microsoft, GitHub, okay. And then authentication code, so much stuff. 951 423. Okay. A little hassle. Add this IP, connect. And we are done. We have connected and we have a database, a sample database actually. So it should have sample data if I understood correctly, because I selected such database. Yeah, perfect. Yeah, so this is the Adventureworks sample database. If you Google up Adventureworks, I'll type that in the chat. If you Google up Adventureworks, that's the database you get. If you select sample database, that's the database you get. So this is how a database looks like. As I mentioned, a database is made of tables. A table is made of columns and rows. So if I right click, select top 1000 rows, it generates a query to select data from that table. And again, it looks so similar to what we had here, as if it was a CSV format, but it's more complex than that. What is happening when we execute this query? I will run this query again. And now you can see an interesting overview. So it tells what happens under the hood when this query gets executed. And there's actually a lot of stuff going on. There is a lot of stuff. How many records are there first? Let's see. Right, I made a typo, no problem. There is 847 rows. So here is an interesting thing. If I, let's say, try to get person customer whose ID is This? Whoa. Okay. Copied wrong thing. Whose ID is this? 3. The result will be interesting. Number of rows read, 1. Let's try with title. Mr. Okay, more like first name. Glenn. Two people. Okay. So notice an interesting thing. I did a lookup based on person's name, right? The person's name was Glenn, and it read 847 rows. As you can see, number of rows read. I cannot really show, but it's 6th option from top. Number of rows read, 847. However, if I do a lookup based on ID, the results will be interesting. Because number of rows read is 1. So when you deal with databases and you want to optimize stuff, you need to know what to filter on. And the thing that you should be filtering on is an index. Specifically, in this case, customer ID, because it's the key. If you do a lookup by a key, that's the fastest way of getting data. And I just proved that by inspecting this execution plan. What you see here is a query execution plan. All the statistics that happens under the hood when you run this thing. It's cool. So this is database, and this is how it works. Now, what can we do about it? What is this syntax? What does this even mean? So, to summarize again about the database is used for storing and getting data in an optimal way. It doesn't just store data, it does so perfectly. It does so that it's blazing fast. The fastest way to get and store data is from a database, and there is no faster alternative, for now at least. There are different kinds of databases. There are SQL databases, which you can see now, like SQL Server, which you can see now. But there are also databases which don't rely on SQL, called NoSQL databases, like MongoDB, MariaDB, RavenDB, and CassandраDB, CosmosDB, and many different more databases. However, the most popular databases, due to the fact that they were the first ones and they have the most mature ecosystem, are still SQL databases. And now it's time to delve into how do we communicate with SQL databases. We already have this query, which actually should look intuitive for even a non-proficient user. If you haven't seen this before, this should still look familiar. I mean, it literally reads like English. Maybe a little broken English, but still English. So SQL is a language to query data. Actually, it's a language in general to manage databases. You can do anything with a database through SQL. So let's simplify everything and write a very simple query. The most simple query that everyone should start from. How do you get all data from a table? You do write a select statement. Select. Everything means a star. So I select everything. From where do I select stuff? Well, I select it from saleslt.customer table. And if I run this query, you will see that, well, the results are returned neatly. So running SQL is very simple. Writing SQL is very simple. And actually, as a beginner, the complexity won't get much more than this. SQL is really easy. So this is a basic select. Let me write a comment about the syntax. Select everything from table. Let's write another one. Select column 1, column 2 from table. So really, basic selects are either select everything or select just a few columns. So you can specify what columns to select. And let's say I want to know person's title, and I want to know person's first name, and person's middle name. From sales LT customer. Perfect. If I run this, again, exactly what I want. Actually, I wanted last name. First name and last name. I don't care about middle name. So here you have it. Title, first name, last name. Very simple. When you talk about SQL, or actually when you think about data in general, you should think about 4 operations. How to create, update, delete, and select data. For now, we only have 1 operation written. So let's write the remaining 3 operations. How do you delete data? And again, it's very simple. You write a delete statement. Then you say where from do you want to delete data? And you say a table name. But a delete operation is a very scary one. It's scary for one simple reason. If you don't provide a filter, what do you think how much data will be deleted if you don't say what you want to delete from a table? If you don't specify? Would anyone care to guess? Guess what happens if I write delete from sales LT customer, and if I execute this statement? what happens with data? It will be blazed, burned to the ground, and there is actually no even possible way of restoring it unless you had a backup. In our case, we don't have a backup. So you need to always follow up a delete statement with a filter statement. So in this case, we don't need this. In some SQL versions, this works, but it's optional because essentially we do not delete a column information. We completely cross out the whole row. When we say delete, we delete a row. We don't delete a column. So we don't need to say all because we already work always with all columns in a row. So let's again select something so that we know what we could delete. Let's say we have John Ford. Actually, let's delete everyone whose name is John. Or let's delete John Ford. And some people could say, well, I could just say first name, last name, Ford. But that's not the right way to do it. That's a little risky. The best way to delete stuff is by providing an ID. So ID should identify a single row. So if I know the row that I want to delete, I can pass it. So let's say I want to delete Karen Hanif. So I'll just say where customer ID is 23 because it refers to Karen Hanif. If I run this, it performed interesting stuff, but I won't analyze that. It said 1 row affected, 7 rows affected, 1 row affected. What do you think could that mean? Why were there 3 entries for different rows affected? Would you try to guess? The answer to this question is that SQL databases are relational databases. It means that it has data with relationships. It doesn't mean in this case that it checked so many rows. Don't mix this thing with statistics. It's not the same. This thing shows actually how many rows were touched. It didn't show how many rows were scanned or read till it was found. It showed how many rows were actually modified in some way. Updated, deleted, created, doesn't matter. But that's the amount of rows that were somehow affected. So it's 9 rows that were affected. And actually it printed it 3 times. So it means that when I deleted a customer, I also deleted 7 entries that belong to that customer, and then I deleted 1 more entry that belonged to it. So actually, if we look at the customer columns again, we'll see something interesting. a customer has what? It has an actually, I don't know what related data was deleted. I assume customer has an address, and customer address was deleted. And then I assume customer also had products bought. Sales order, probably. Yeah, so if we select a sales order, we should see that there is a customer linked to it. Yeah, you can see here. So that number 8 that we saw there referred to 8 orders deleted along with the customer, just like that. And one row probably referred to its address, customer address. And I don't know what one other row referred to, but it doesn't really matter. What matters is that the way SQL works is that you can configure it so that no invalid data is ever possible. For example, if I demolish a house, all people inside that house no longer live in it. They moved out. So the link for those people with that address should be gone. That's the beauty of SQL Server for in general relational databases. They are set up in such a way that data is almost never invalid. You might sometimes struggle inserting data or updating tables for that reason, because it does extra work to ensure that no invalid data is in a database. All right. And a tip, what you should do before a delete, you should, if you want to perform a delete like this, you should always double check if you're not deleting something that you don't want by accident. So the best way to check what gets deleted is by running a select statement. So again, let's say I want to delete all people with name John. I could write this. But I don't know what gets really deleted, and that scares me. So instead, I should write this with the exact same select. And now I know what people will get deleted. If I run this, I know, okay, 20 people will get deleted. So I can run this delete with certainty, knowing that 20 rows will be affected, and then some more. Oh, run. What's wrong? What's wrong? What's wrong? The delete statement conflicted with the reference constraint. Okay, that's interesting. I did not expect that. I don't know what went wrong, to be honest. I will just delete by some other criteria. This is the difficulty that I just mentioned. It sometimes doesn't work because the way it's set up, it has relationships and guards and constraints which don't allow you to really do stuff sometimes. Actually, let me try to do it one more time. So the whole idea behind it, I take the same criteria, I select the record, I see it's there, so I expect one record will be deleted, and now it's there. Wildcards on my constraint. I don't think it would help, to be honest. I don't think it would help. Wildcards are those symbols, by the way. I will add it on delete as well. Nope. Didn't think it would work. It doesn't matter that much. Usually the delete happens through an ID, not the name. Sometimes through the name as well. But I was not the one who made this database, so I won't invest the time in finding the error. It's not the point of this lesson. The point is elsewhere. The point is to get the basics of SQL and databases. So this is a basic select. This is a basic delete. Let's move on to another one. So let me write a comment, wildcard. Get all people who has a name like John. For example, A John, A John, Jonas, and so on. Okay. We know about select and delete. Now we need to write an insert statement. How do you create something? So insert, I always get mixed up actually with the syntax of insert. Insert, then you specify columns, I think. So we'll specify these columns. And then you say into what table. The table will be sales LT customer. Values, and then you specify values. But I messed it up somehow. Insert into. I think it's like this. Insert into this table, these columns, these values. Yeah, sorry. I always get mixed up. Insert into table, columns, values, values. Okay. Customer ID will be 99999. Title will be Mr. First name will be my name. And I will even review my last name. Let's try it out. And it says, cannot insert explicit value for identity column. That's what happens. If you look at customer ID, it's actually a public key, and public keys, when they're numbers, they're usually generated, automatically incremented. So I don't really need the ID to provide the ID myself. And in fact, if you did have to always provide an ID yourself, wouldn't that be hard? I mean, why not use luxury that database gives you and auto-generate the ID on the fly? Okay, so password hash, cannot insert the value null password hash. So every user has a password apparently, and I need to provide that as it's a mandatory field. So let's say That's my password hash. And then it said the salt is also needed, so I will provide the salt. All right. Let's continue. Now it wants me to have it's too long of a salt, so let's shorten it. And here we have it, row inserted. So let's get the customer that I've just created with my name. Not deleted, but get it. If I run this, you can see me. I've been created, born anew. Taylor AI asked, if you delete an entry, will the ID slot be empty or does it shift all? That's a great question. What happens if I delete myself? So the idea was this. I'll copy it. That's what we had. By the way, those two minuses, that's how you write comments in SQL. Minus, minus, and a space is a comment. So, the ID was 30122. If I delete myself and insert myself again and select myself again, 30123. So technically, you could fill those slots. Technically. But SQL doesn't bother. I don't have a good reason for that. My only guess would be that it would require a little bit more compute to find a hole in the IDs and fit the entry in the right hole. Therefore, they just it's a counter, it just goes on and on and on, so you don't care. If you didn't generate IDs, yeah, then you could fill those holes yourself if you cared. But SQL doesn't. If you generate IDs, like automatically, if you automatically increment them, it's out of your control. You cannot fill the holes. I haven't seen anyone who does that. Maybe it's possible, I don't know, but as far as I know, no one really bothers. I mean, you won't run out of space. I mean, it's not a hole. It's just a like you in the end you maybe miss like a third of all possible values for IDs, and an ID is like can have a billion values. So I mean, if you have a billion rows in your table, you won't have that. it's not an if, you won't. And if you do, probably the format for storing the ID is just the wrong data format. So it's a small problem and no one really cares. So don't worry about it. It might bother at the start, but you will get used to it. All right. So that is the database. We have select, delete, and insert. And the last one is an update. So update table set value equals x value 2, well, column equals value 1, column 2 equals value 2. Very simple syntax again. So let's update my middle name. I actually have a middle name. Well, I don't have a middle name, I have a second name, I don't know actually in my country how is that considered, but my middle name is Matas. Matthias, I guess, in English. So let's try to do that. Update sales LT customer. Set. So middle name, because let's get the middle name beforehand so that we know it's null for now. Sorry, wrong place. And here, middle name, please. So you can see my middle name is null for now. So I'll set my middle name to be Matas. And I almost wanted to execute this. Why shouldn't I ever execute such update statements? Why? What do you guys think? If I press the execute button now, what do you think will happen? And I will do so, since it's just a sample database. Suddenly, all customers have the same middle name, Matas. Because just like delete, I did not add a where statement. And again, there is no way to bring this back unless you had a backup. So it's a big problem. It's a big problem. But it's a dummy database, so we don't really care. What we do care is that the customer, me, now has a proper name, proper middle name. And that's really all, the essence of SQL. The only last thing that you should remember about, like, the very basics of SQL is how do you combine different tables together. For example, remember, sales header refers to a customer through customer through customer ID. But how do I get back to that customer? It's just an ID. What do I do? So let's delete everything. Select all from sales LT dot sales order header. Let's go. And I want customer ID. What else do I want? What information would be relevant from this order? Well, obviously order ID. The dates would be relevant. Shipping date, for example, and order date probably. Probably order ID is not as important as order number, so I'll replace that. Ship to address ID, bill to address ID. And subtotal tax, subtotal, that's the last thing that we care. So if I run this, that's fine, but how do I know who is customer 29847? And the answer is, again, what do I want to achieve? I want to get data from different tables. How to call this differently? I want to join different tables. I want to take two tables and stitch them together. So I literally call it a join statement. So I say select these columns from sales order header and join sales LT customer, because that's where customer data is at. When I perform a join, I need to provide a condition. How do these two tables link? So I say join those tables on this condition. So join these tables on this condition. So I'll say sales LT dot sales order header equals. So I need to say what from this table refers to what from the other table. So they're both linked through a customer ID. Sorry. Yes, like this. Sales order header, customer. Not sure what's wrong. Don't see it yet. Anyways, I always like putting aliases because, like you see, it might become confusing what you're ordering. So I'll just say this is a header, and I'll just call this a customer. So we got customer ID from here. And we join header customer ID with a customer ID. It makes things less confusing. And as you can see, the error just disappeared. I don't even know what error that was, but simplifying things helps. So as is used for aliasing, for giving a table a human readable name, simplifying it in a tiny, tiny scope that this query is. If I run this query, it's not changing the results that I got, really. Well, it kind of is, kind of not. It just added duplicate data. I still don't know what the customer, who the customer is. And this is because just because I joined the two tables doesn't mean I'll get their data right away. I still need to specify what I'm getting. So I want customer's first name and customer's last name. That's all I want from customer. I also like separating stuff. What's customer, what's sales order, and what's, oops, oh, and what's addresses. So I just formatted, double checking if it works. It does. So you can see now I get person's information, which is great. And I want also a address. Where does it get shipped? So I'll need to join one more table. And that is customer address, I think, or just address. I think it's just address. So sales lt dot address. On, again, what do I join on? On, so I join header, ship to address, ID to address ID. So this will allow me to write address. So I say I'll say address. This is shipping address. So shipping address autocomplete. Shipping address. Let's see what address has. Address line 1, address line 2. I care about city, let's say. That will be good enough. As shipping city. And if so, let's run this. And you can see now it prints a shipping city, but it still doesn't print a build to address. So I would need to join again, because even though it's the same table, it's different ID. I join a different thing, so I need slightly different thing. As billing address on header dot ship build to address ID. So I can now replace this with billing address dot city as billing city. And if I run this, you can now see that most records have the same billing and shipping cities. In fact, all of them. Let me double check. Let me double check if that's really the case. Let's mess it up a little bit if it is the case. Yeah, it does seem to match in all cases. What a boring database. Let's make it more interesting. Update. Sales LT dot header set ship to address ID. Let's send it all in one place. Imagine if someone actually made this mistake. Like, imagine if someone did something like this, ever. And some person, some poor guy, suddenly gets a shipment of hundreds of orders. That would be, I don't know if it would be more funny or sad. Up to you to decide. But I just wanted to make this distinction that the two addresses are actually different, and that's why we needed two separate joins. So that's the join. It allows us to combine data from different tables in, again, a very easy way. For now, I wouldn't like to give any more problems than there already are, and I would like to stop for today in this place. Next time, we will try to delve into how to create our own database from zero, our own tables, our own database, how to actually design it, what principles to follow, and why you need to follow those principles. So that would be all for today. But before I go, would you like to ask me any questions? I'll save this SQL. I will try to create a branch with homework and exercises for you to try. To create your own database, I highly recommend trying Azure. It's nice experience. It's quite straightforward. You don't need to know much yourself. Oh, it actually shows statistics of utilization. It was 10% utilization for our queries. Nice. So I highly recommend to try the same stuff. Follow the video along, create a subscription, add a resource, make it a database, create your own server. It's pretty cool. I actually, under the hood, also created a virtual machine. Okay, I didn't, so ignore that. I didn't, but I can if I want to. But that's just goofing around with Cloud. Try Cloud, it's fun. Try SQL Server Management Studio. It's very convenient, intuitive, and play around with query execution plan analysis. Don't forget to tick this little box right here when you execute your queries so that you can get those nice statistics out. And that will be all for today. Thank you all and see you on next Saturday. Bye bye.